Alright, so this video will be over chapter 3.2, addition of whole numbers, and one type that we can add whole numbers is going to be the lattice algorithm. So we're going to start out simple, and we're going to start by trying it with a two-digit number, adding with another two-digit number. So my first number is going to be 72 plus 63. Now these numbers both have two digits in them. We have a 7 in the tens place and a 2 in the 1 for 72. And we have a 6 in the tens place and a 3 in the ones place for 63. So how the lattice algorithm goes is for each digit that you have, you want to make a box. So just like this, I have two digits in both of my numbers, so I want to have two boxes at the bottom. And then I'm going to split each of those boxes in half to represent the addition that's going on. So our first addition problem, first part is going to be 2 plus 3. 2 ones plus 3 ones. And we're trying to figure out what the answer to this problem is. So the answer to 2 plus 3 is going to be 5. And the way we write it is we're going to put a 0 above the 5. Basically this means that our answer was 0 tens and 5 ones in that box. Now we're going to move over to our next column where we have 7 plus 6. And if you're not familiar with 7 adding to 6, you can always think of the problem 6 plus 6. 6 plus 6 is a double and it makes 12. So if you're confused, you can do 6 plus 1, which equals 13. Or you could just simply add 1 to 12. So it's going to be 13, which you can see is a two-digit number. It has both a tens place and a ones place. So we're just going to denote that by placing it into our box here. So I have a 1, a 3, a 0, and a 5. This problem is not, the answer to the problem is not 1,305. The problem is actually not done solving yet. So I'm going to take a different pen here so we can kind of notice the difference. And I'm going to circle at the crossing, at the angle, the digits. So I have my 5 here, I have a 0 plus a 3 here, and then lastly I have a 1 here. And basically each of these diagonals is going to be my place value. So for my 5 I have my 1s, for my 3 plus 0 I have my 10s, and for my 1 I have my 100s. Alright, so when I do add those problems up, 5 plus nothing is just going to be 5, so I bring that down. 3 plus 0, because we know that anything plus 0 is the other number, we're going to bring it down. And then lastly, 1 plus itself is going to be 1. So the answer to the problem, 72 plus 63, is going to be 135. Alright. So that's what the problem looks like with a two-digit number. So let's go ahead and try it with a three-digit number times a two-digit number. So we have 565 plus 772. Okay, so just like before, 72, bringing it down. So what's different about this problem is that I have a three-digit number plus a two-digit number. So in order to accommodate all of my numbers, I want to make sure that I make a box for each of the digits. Now, even though this one has 2, we can have kind of a phantom 0 in the front here. So I'll just, little phantom 0, because there is nothing in the hundredths place, but we can always place a 0 there if we feel more comfortable that way. So I'm just going to create my little diagonals here. Alright, I'm going to try to make this a little bit clearer with using my black pen. So just like in the first problem, we're going to add the columns one by one. Okay, so we're going to start here. So 5 plus 2 is 7. So we're going to mark that with a 0 in the tens place and a 7 in the ones place. Now that we've gotten down with this column, we're going to move on to the next column. Again, we can reference this math up here if we're curious about 6 plus 7, but from before we do know that 6 plus 7 is 13. So I'm going to bring a 1 and a 3 down. A 1 to represent the tens place and a 3 to the ones place. Now lastly, we're going to go to this last column here. We have our 5 plus our phantom 0. 5 plus phantom 0 is, of course, just 5. We have a 0 in the ones place. That's not to be saying that the 5 went straight here and the 0 went straight here. It's when you add these two numbers, they equate to 5. So again, we're going to go in and circle our diagonals to figure out our place value. So in our ones, we have a 7. In our tens, we have a 3. In our hundreds, we have a 6. And you can see here that we could go to the thousands, but our thousands value is at 0. So when you take off this thousands, it's going to turn into 637. So 637 is going to be our answer to this problem. 565 plus 72. All right, let's make it a little bit more challenging, and let's go ahead and do a 4-digit number by 4-digit number. All right, so I'm going to use the number 8,399 plus 1,779. All right, so already we want to go ahead and create our lattice. And we have 1, 2, 3, 4 digits. We have the ones, tens, hundreds, and thousands. So we're going to make 4 boxes at the bottom and place the diagonals inside them. All right, and just to make it a little clearer, I'm going to switch my colors so y'all can see. So our first problem is going to be 9 plus 9. Now I know my 9 facts very well, so this problem came very easily to me. 9 times 2, or 9 plus 9, is 18. Now if you didn't know that, you could also use 10 times 2 equals 20, and then since you're one step away from that in each of it, you could do minus 2 to figure out that that number is 18. But just like before, 18 is a 2-digit number, so you press the first digit, as in the tens digit, into this little square, and the next digit into this one. So now we have 9 plus 9 equals 18. So we're going to move on to our second column, where we have 9 plus 7. And just like before, if the 9 facts are a little bit of an issue, we can do this sort of thing. All right, so I know that 9 plus 7 is 16. So I'm going to bring it down there. Next digit, we're going to go to the hundredths place. And I see 3 plus 10, and I know it takes 3 digits to get 7 to 10. So I'm going to place a 1 in the tens place and a 0 in the ones place. And last thing I'm going to do is I'm going to put 8 plus 1, which is in my thousands place, and I know that that is 9. So I'm going to place a 0 in the tens place because we have not made a 0 yet, and a 9 in the ones place. We're still not done. We still have to figure out our diagonal sums. So first things first, we had an 8. 8 plus nothing because it was all by itself. Next column we're going to go to for our tens place is 6 plus 1, 7. Next column we're going to go to is 0 plus 1 to get our hundredths, and our hundredths value is 1. We're going to move on to our next column, and we see a little bit of an issue. I know that 9 is the last digit you can have in a place value, and 9 is being added to 1. All right, so we know that we're going to actually go up a place value. So I'm simply going to place my 0 down here, just like the rest of my ones, and I'm going to place my 1 up here at the top. And now this allows the 1 to be in the next place value. Okay, so I'm now going to circle all my numbers in this column and realize there is a 0 plus a 1, and 0 plus 1 is 1. So now we have my final number, which is 10,178. All right. So that is it with lattice addition. Hope you enjoyed.